So just for information, the meeting is being recorded so that you are aware. Especially also for the people online, please be aware that we are recording the meeting. I hope all of you have found a place to sit. The other thing is, please, if you haven't signed the presence sheet, which was outside on the table where the nameplates were, do so in the coffee break. And then I think for the official welcome, I'm going to hand over to Jürgen Tiedje.
Good afternoon to everybody. For those who don't know me, my name is Jürgen Tiedje. So I'm heading the team in DG RTD, dealing, amongst others, also with safe and sustainable by design. So I understood 600 people here are in the room or listening from outside. That's great. It's the third SSbD workshop, and I should underline it's about case studies today. So it's not about big policy, it's about case studies. We all know a lot has happened last year, the year before, so I will not recap you the chemical strategy for sustainability. This is for other fora. SASCM, many other initiatives are also other forums. Today, we have had two achievements on the side of research innovation. First, we published the SRIP, how it's called. This is our strategic plan on research innovation. And we published a Commission recommendation on safe and sustainable by design on the 8th of December. The recommendation is about a framework, and we had our politicians here in Berlaymont indicating we should test this framework, and this is very much about. For us, both documents are big achievements under the Green Deal. We are moving on something positively forward, and all the reactions we get so far, it's good that you start moving. We need to look more into the details, but in particular on safe and sustainable by design, it's the right move now. We are cautious. As I said, it's testing a framework. It's not meaning we apply it as from tomorrow and ticking the box. It is really important. I would like to underline this. Quite clear, I mentioned already that we have 600 people following it today. So shows again how well we are obviously connected with you, I hope. We will see the reactions later on. But it shows again our commitment to interact with you. Maybe I come now with three thoughts on this. First, it's about towers, and then I come to steps, and then I come to the house, and you will explain what I will explain what I mean. Brussels is very often seen as an ivory tower. So you should help us to get out of this ivory tower. And your leader today will be the Joint Research Center, which will be with us. We're working on a big framework and on the implementation on case studies, and I suppose that will be at the center of many presentations and discussions today. So good to have you here. The other tower is we need to have an understanding of the framework and of the various steps. So case studies is indispensable. We don't want to land like, I was tempted to speak about the Tower of Babel, many languages, sky-high expectations, total chaos. This is what we don't want to have. We want to have a good framework which works, which gets tested, which gets discussed, and where you feel really your concerns, your questions have been, you could have raised them, and we looked at them. So for us, the half day this afternoon, and I think we have tomorrow morning also a long session. This is really great that you took the time, and please stay connected in this regard. Your support is fundamental for us for the implementation of this framework. And we would like now to get much more operational when it comes to the framework dealing with safety and sustainability. Yeah, and we will discuss preliminary findings on the case studies from the Joint Research Center. So you take us the first step out of my ivory tower. That is really great. And now I spoke about towers, I spoke about steps, and now I'm speaking about the house because we have some housekeeping rules, if you allow me. We are using WebEx for those that they can connect. If you have questions, and we will show this later on, you can use Slido. Please, questions only via Slido, not via WebEx. Otherwise, it's a bit too much for us. That's one point. Please, in WebEx, keep your microphones off. This is not about us, but protecting your private life, because that we don't want to follow. I think I'm very happy to be here. So the main reason for me coming here is not to give a welcome speech, but actually to listen to you also for the rest of the day. So Alexandra Meliska from DG Environment. Over to you.
Thank you, Jürgen. If you can go to the next slide, please. So, hello to everyone. I'm Javier Sanfelis, working in DG Research and Innovation in the Industrial Transformation Unit with Jürgen Tiche, and together with Alexandra from DG Environment, we will give a short introduction on the recommendation that has been adopted in December last year. We will also go through the activities that are currently ongoing, and then give an overview of SSbD, safe and sustainable by design within the chemicals strategy for sustainability and other related activities. Next slide, please. So, as you all know, the Commission adopted this recommendation in December last year that proposes a framework for safe and sustainable by design chemicals and materials to be applied in research and innovation activities. The recommendation is addressed to member states, industry, academia, and research and technology organization, and it opens a testing period for this assessment framework that it is included in it. And the objective of this testing phase is to being able to improve the relevance of this framework, make it reliable and operational for the end users. And afterwards, the results of applying this framework can contribute to the definition of safe and sustainable by design criteria. Next slide, please. And as I said, the recommendation is addressed to member states, and what we are expecting from them is to get engaged in the promotion of safe and sustainable by design actions in the research and innovation programs, and report to the Commission during these 2 years of the testing period. So we expect from member states to come back to us with how they are promoting SSbD in their national research and innovation programs, if they are contributing to increase the availability of fair data for SSbD assessment, in case they are also supporting actions to improve assessment methods, models, and tools, and also actions related to development of educational curricula or skills, all related to safety and sustainability for chemicals and materials. Next slide, please. Then the recommendation is also addressed to industry, academia, and RTOs. And here, the engagement we are expecting from them is quite similar, but in this case, on applying the SSbD framework in their internal research and innovation development process for chemicals and materials. And of course, we hope that they will engage in the testing period and provide feedback on how this experience of using the framework in their internal processes is working, and also if they have taken actions to improve fair data for the assessment, improve assessment methods, models, and tools, and as well supporting the development of professional training and educational curricula. Next slide, please. So the assessment framework that is included in this recommendation is based on the work that the JRC has been doing in the last 2 years, and that we have consulted with you in the last 2 workshops that we had in 2020 and 2021. Sorry, 2021 and 2022. And in this recommendation, in the annex, we have included 4 assessment steps. I will not go into the details because this is part of the workshop today, but what I wanted to present here is that you probably are aware that there is a step 5 that is included in the JRC report that will be also presented today. This is still work in progress to see how socioeconomic aspect could be integrated in the SSbD framework, and it's part of this testing period for the next 2 years to discuss with all of you how and the potential integration of these socioeconomic aspects in the overall SSbD. Well, here I mean, this information that you have below will be presented already by JRC afterwards, but the steps can be performed in parallel as information becomes available in the life cycle stages or as you are progressing in the innovation process. And this framework will help you, will help companies in the different stages of the innovation processes, where decisions need to be taken in order to improve safety and sustainability performance. And the next slide, please. So we are, with this recommendation, asking engagement from industries, member states, academia, and RTOs, but how is the Commission supporting? So we already included in the Horizon Europe Work Programme for 21-22 a number of topics on SSbD. There were 3 on developing SSbD materials, and we also had coordination and support action that is the project fund that is called IRIS, and will be developing a European network on SSbD experts and also develop roadmaps for value chains for certain chemicals and materials. Another action that was launched in this work program is the partnership on risk assessment of chemicals that includes a dedicated work package to develop a toolbox for the assessment of safe and sustainable by design chemicals and materials. Now, in the current work program for 23-24, we have under cluster 4, which is the cluster on digital industry and space, where our unit in the GRTD is contributing with topics. We have 3 topics for the year 2023, one related to improvement of methods for safety and sustainability assessment, another one on integrated impacts, taking into account safety aspects and the 3 pillars of sustainability. Another one on developing modeling tools for the design of advanced materials, integrating the SSbD framework. And these 3 calls are open now until 20 April of this year. So this is also an invitation for you to go to our funding and tenders portals and create a consortium and apply for one of the calls and make a project proposal. For 2024, we will have also another topic on the development of SSbD chemicals and materials. And on top of that, we have also added reference to the use of SSbD as a tool to improve safety and sustainability in the development of chemicals and materials in other clusters of Horizon Europe. And this is cluster 5, which relates to climate, energy, and mobility, and especially on topics related to the design of advanced materials for battery applications, and also on cluster 6 with the food bioeconomy, natural resources, and agriculture. We also have discussions with the joint undertakings, one on the Innovative Health Initiative, and also on the Circular Bio-Based Europe. So these all are funding opportunities that we are putting in order to support the testing and the use of the SSbD framework. And on top of that, during these two years of the revision of the testing phase of the framework, we will have the methodological guidance from the Joint Research Center that will continue working with us and supporting this action. And with this, I'm going to hand over to my colleague Alexandra, that she will continue.
Thank you very much. Can I please ask for the next slide? I think that from what you have just heard, and also observing how many of you are present, and also how many representatives from our side, from the European Commission, are here today, it's obvious to see that our very intense work originated 2 years ago with a lot of effort to develop and to adopt the framework, has not stopped with the publication and adoption of the framework that Javier just briefly reminded you about. We are fully committed to continue our work within this testing period, and there are several activities and initiatives that will support our engagement and also exchange with you, as we really count on your participation to help us to develop and to define criteria for safe and sustainable by design chemicals and materials. And for that reason, we will organize 2 stakeholder workshops, 1 per year, that will be dedicated to hear from you, to collect your input, to collect the lesson learned and experience from the implementation of the framework, and to address the challenges, that issues that you might raise. But it will be not only listening and hearing your input, but based also on the latest development, on methodologies, on tools that will be needed for the safety and sustainability assessment within the framework. We would also provide you some guidance how to proceed with the assessment. All of this work is really dedicated and committed, as mentioned before, to define the criteria for safe and sustainable by design chemicals and materials, and to revise the framework if needed, of course. If the implementation phase shows that everything works excellent, maybe the revision will not be needed, but of course the time will show. I just wanted to stress that this approach is very much aligned and addressing the request that we got from you. To be able to first test the framework before coming up with the criteria. So I really hope that you will use this opportunity to get involved. Can I please have the next slide? But before diving into more details and going directly to listen about the application of the framework to the case study that will be presented both by our colleagues from JRC, but also some lessons learned by the companies involved, I would like to remind you and recall the broader context in which the Safe and Sustainable by Design framework was developed and will be implemented. This is not a standalone activity, but it was foreseen as among over 80 other actions in the chemical strategy for sustainability that strives to support transition to safe and sustainable chemicals. I think it's not a surprise for the people following this workshop and this work to understand how important is it to develop safer alternatives for chemicals and materials in order to achieve the broader goals that are included in the Green Deal, such as transition to circular neutrality, climate neutrality, circular economy, and to achieve zero pollution ambition. And there are a lot of other means foreseen in the chemical strategy for sustainability that could support the work that is being done here under the Safe and Sustainable by Design framework. One of which Jürgen very nicely already mentioned, so it's a strategic research innovation plan, very important file that aims to steer the innovation and stimulate the development more safer and more sustainable solutions. Similarly, something that was already mentioned by Javier, targeted funding opportunities. On one hand, to develop tools and methods, on the other, to start embedding the thinking of very early on assessment of safety and sustainability aspect at the design stage, both on when we are talking about chemicals and materials. And last but not least, of course, the regulatory tools that are striving to support, to increase substitutions of chemicals of concern. So also contributing to creating the niche and the need for alternative solutions that are safe and sustainable. Can I please have the next slide? Having said all of that and the multitude of activities that are already ongoing, we are sure and we are committed to look in a broader application and impacts of the use of the Safe and Sustainable by Design framework. As mentioned already, of course, we want to steer innovation towards the green and industrial transition and substitute as much as possible and of course, minimize the production and use of substances of concern. But this, in turn, we hope that contribute to minimizing the negative impact of on health, climate, and environment the chemicals and materials still have today. Can I please have the next slide? Many of you are very much aware of other ongoing initiatives and mentioned there are about 80 actions that were announced in the chemical strategy for sustainability. And I wanted to reassure you that internally we are really doing our best to make sure that there are maximized synergies between the ongoing actions. And I think one of the good example is the fact that we are both sitting here, so colleagues from DG Environment together with colleagues from DG RTD that are involved in other activities that are relevant for chemicals. What is really important is that we want to see that already ongoing initiative can benefit from, but also contribute to the work of the Safe and Sustainable by Design framework. And we need to remember that we are still in a testing phase of the framework. This is very important to announce. So the ongoing work in the different work stream can be very useful for this testing phase. For example, work that is being done for REACH will generate information that might be needed to perform the assessment of safety and sustainability of chemicals and of chemicals in this matter. Similarly, when talking about the development of new approach methodologies, the information generated thanks to use the NAMs could also benefit the first step of the assessment and to avoid testing on animals. There are a lot of other ongoing initiatives, both on the European level as well as at the member state level. They are addressing the data platform for chemicals. Already there, we are looking and specific objectives are incorporated to support safe and sustainable by design chemicals. So these links are already included. We are doing our best to ensure the synergies, but that doesn't mean necessarily that whatever is developed here will be directly implemented in other initiatives. And I would really like to stress that. Reminding you that Safe and Sustainable by Design framework is really a way to use research and innovation to enable the transformation is really focused on boosting the innovation. Can I please ask the next slide? And with that short introduction, I really do hope that today's workshop would be yet another important milestone for all of us in progressing towards defining workable and good and ambitious at the same time, a criteria for safe and sustainable by design chemical. Within the next 2 years, a lot of new information will be generated. There will be new tools and methods developed that for sure will contribute and will support the development of the framework and its implementation. However, we are certain that there will be some challenges on the way. And we hope not to see you only today, but in the next workshops plan in the year time, when you already have an opportunity to apply the framework, to come back with the first feedback, to raise this concern with us. And hopefully within the next 2 years, we will be able to address that. So in the end, we will have an outcome that we are all proud of and the framework that can be used by you. And with that, thank you very much for the introduction, and I give the floor to our experts.
So, thank you very much for this introduction. Before I hand over to the technical sessions, which will be presented by the Joint Research Center colleagues, I just wanted also to remind you that, well, you see many of us here, as Alexandra already hinted at. We have the GRC, Environment and RTD. We have colleagues from DG GROW online, and there is also part of the colleagues from the Joint Research Center which are online, which will present tomorrow, and they will then also introduce themselves as they present tomorrow. So I think we can really say it is a very joint commission initiative, and we are all behind it. Again, I come back to a practical issue. Slido for questions, please. You can all log into Slido. You have the QR code and the website here. We will not look, so any comments in WebEx will only be if you have any specific technical issues. We will not use them for the discussion. So please use Slido. With this, I will move on to the first session. So I hand over to Serenella Sala. And the speakers, please stick to your speaking time so that we still have time for questions and the discussion. And any questions which have already come in, we will take them in the following Q&A sessions. Thank you.
Thanks a lot, Sophie, and welcome to everybody. I think we will have really an intense afternoon and the morning tomorrow to discuss on the first application. So my role is to give you an introduction on the case studies on the safe and sustainable by design. Next slide, please. So the idea is to illustrate the case studies where the framework has been tested, which was really the objective in the developed case study. And I will introduce what then my colleagues will present you in details step by step. So the non-phthalate plasticizer in food contact material. So the key feature of this case study that has been selected, the chemicals that we selected as reference and the alternatives that has been chosen, the specific plasticizer application, and then just to help you then following, let's say, the logic of the workshop, an overview of the SSbD framework and which aspect of the life cycle of the chemicals is covered by which step. So next slide. Okay, so what we will illustrate today and tomorrow from JRC is the first case study, which is this non-phthalate plasticizer in food contact material that has been developed by us with support of different organizations for which we acknowledge the support, and that will be also illustrated in upcoming slides. Other two case studies has been conducted by industries with some JRC support, just in terms of some methodological exchanges. One on a non-halogenated flame retardant in ICT product, and the other on enzymes in textile scoring. Next slide. So just to set the scene, we wanted to share with you which were the objective of the case studies development, which was actually to evaluate the feasibility and applicability of the framework to assess the selected chemicals, especially trying to push the limits in the sense of really identifying the challenge and the limitations in the application of the framework in light of future developments. Of course, the exercise is meant to pave the way to address knowledge gaps, but also to help us refining the framework, advancing on SSbD criteria definition. Just to be very, very clear, the objective was not to classify the chemicals being SSbD or not SSbD, but it was just really illustrative to see how we can address the challenges that a framework like this is posing. Next slide. So why we selected plasticizer in food contact material? Actually, the three case studies were the results of some interaction with stakeholders on topics of particular interest and also of integrated nature. So where multiple challenges are addressed by the chemicals that has to be selected. In particularly, plasticizer are widely used to improve workability, extensibility, and flexibility of different polymers, and mainly are phthalates, the chemicals that are used there, then terephthalate, epoxies, and aliphatics. But phthalates are restricted in a wide range of products by REACH, by toys regulation, by ROS. And so there are already a number of alternatives proposed in the market of non-phthalate plasticizer and bio-based plasticizer. And then the idea was to consider plasticizer applied in food contact materials because of the wider use, of course, of food contact material, but also because from certain materials there is a release of hazardous substances into food, which are posing health concern to the consumer. And then framing the case study as such, we thought to touch upon, let's say, several types of concerns that chemicals are generating. Next slide. Very briefly, the key features of the case study was, as I mentioned, to refer to a non-phthalate plasticizer in food contact material. We decided to consider as reference the DEHP, so D2-ethyl phthalate, and we start defining some criteria for the alternative to be tested. So it should be a non-phthalate. It should have similar technical properties as phthalate to PVC, and it has to be authorized for food contact material. Next slide. So this is the list of chemicals that we selected. So the reference has been selected being a substance of very high concern under REACH because of being classified as toxic for reproduction category 1B and also recognized as an endocrine disruptor for human health and the environment. Next slide. The other 5 alternatives that has been tested, you will learn a little bit more about them in the different steps because we will illustrate, but just in a nutshell to have an idea why they were selected. The ATBC and the EHA has been selected because those are most commonly used monomeric plasticizer for food packaging in PVC cling films and are already used there as alternative to phthalates. The DEHT and the DINCH are again alternatives to phthalates used in medical device and in food contact material. We decided to consider both because they are relevant in 2 different markets. So DINCH is most used as an alternative in EU and the other more in the US. And then, since there was a discussion on criteria or elements of safe and sustainability that are also addressing bio-based chemicals, there was the intention to have at least one of these alternatives of vegetable origin as representative of these bio-based chemicals. And then this is why we selected the SSbO, which is used in formulation as plasticizer and stabilizer. So next slide. Okay, the specific application that has been selected is an application of a sealing gasket made of plastic liner with elastomeric properties. So plastisol placed below the metal cap in a glass jar. So this specific application has to be designed and defined to be able then to set the requirements in terms of modeling in relation to the potential release of substances from the application and also to properly set the life cycle of the production, the, let's say, coupling of this gasket with the metal cap and so on and so forth, including, of course, the end of life. So next slide. So if we recap on the overview of the framework, as you know, there is an initial phase, which is the phase in which, in the definition of a new chemical, there are certain design principles to be followed. We decided to apply alternatives to consider as case studies, alternatives which were already in the market. So this design phase has been not taken into consideration in the development of the case study, but we were zooming already into the different steps. Next slide. Okay. So the idea of the safe and sustainable by design assessment is really to look at everything which is happening in terms of possible implication on human health and the environment along the life cycle of a chemical, so along all the stages. So the system boundary of the study was going basically from the raw material that are behind the precursor of the plasticizer to the compounding, the gasket manufacturing, the gasket use, and the end of life. Of course, due to the peculiarity of the assessment in each step, not all the stages were addressed by all the steps. Specifically, next slide, you will learn from the colleagues illustrating step 1, an application which is focusing exclusively on the properties, on the physicochemical and toxicological properties of the plasticizer itself, so the chemicals. And in this case, to be helped on the identification of the plasticizer, but also on the certain aspect of the characteristics, we were in contact with CEFIC and with Plastic Europe. Next slide. For step 2, this step is actually addressing the production and processing step in the system, assessing the worker exposure to the plasticizer. So it's embracing almost all the steps of the system boundary set for the entire assessment. Next slide. In the step 3, we zoom specifically on the gasket use, so mainly focusing really on the use phase. Next slide. And finally, on the step 4, which is based on the life cycle assessment of the chemical, all the steps were covered, and of course we were interacting for the different steps with different organizations, really to be able to design the processes and to get an idea on how to best model certain aspects in a realistic manner. As announced by Javier, more in terms of a sort of explorative approach, we will present also the results of the assessment for what concerns the socioeconomic sustainability assessment. And again, for this, we are embracing the entire life cycle. So let's say the system boundary is the same as for the life cycle. So I have just to conclude now, acknowledging again all the colleagues that helped developing the case studies inside the JRC and outside in the DG Environment, in the GRTD, but also those that were in a working group internal to the Commission, but of course also to all the actors that were, let's say, giving us all the support to be able to develop the case study at the maximum possible in the constraints of time and resources. So I think we can open the Slido also for this part and then progress further. Thank you very much.
Thank you very much. Just, we would very much welcome if, when you use Slido, and especially also for the people online, that you could identify who you are and maybe, you know, the company, organization you belong to. It would really help us instead of just having anonymous questions. I'm going to open the possibility to ask questions first in the room while people online can get connected to Slido, and then we will go a little bit to the Slido questions afterwards. So first of all, are there any questions in the room? Yes, I see down there. Please also always introduce yourself.
Hi, everyone. I'm Eva Leinala from OECD. So I'll try to jumpstart the discussion here. One observation is you mentioned that you skipped the design goal step. And I wonder if the case study could have benefited from thinking through the design goals. So recognizing that it's existing chemicals that are used, but you are redesigning something. And that would help you then weigh the different attributes in the end. Because if I think through the case study, I think the design goal was essentially to use a drop-in replacement for a particular material and not change any of the other ingredients in the material, and try to reduce the reproductive hazard and potentially improve other environmental attributes. But you could have had a design goal that maybe looked at the whole plastisol and are the phthalates the main safety or sustainability issue with the plastisol, or could the design goal have been broader to maybe then bring in other environmental considerations. So I think it's just maybe still integrating that design goals to then help us at the end bring together all those different attributes and how you deal with those. So, thanks.
I think indeed this is probably the ultimate goal in the sense in a more mature development of the framework, in the sense that the idea of design and redesign was basically thinking at the beginning to say, I have an alternative to a chemical, or I have some means to identify hotspot along the life cycle of this chemical that I can redesign, so the redesign of the process. Of course, if I now think about something which is where the chemical is used, that is, let's say, for me, an additional step, or a step that could start as from the beginning, that you do a screening assessment of your material, you see which are the components that are driving the impacts, and then you go into the SSbD assessment of those that are driving the impacts. So it's, let's say, somehow the philosophy behind the innovation. If the idea is, I mean, we took the example of someone that is really the plasticizer producer, but of course you might be the one that instead is buying the plasticizer to produce the product, and in this case, the gasket. Or you can even be the one that is producing the entire jar, so it will have already a product there and may select, and at the end saying, I'm not using this jar, I'm using a different packaging. So it's really very much the starting point of who is innovating. But what I think we have to see if the framework may work at least at the level of individual chemicals and materials, because this is the main focus now of the recommendation that we have.
Thank you very much. I think I would like to take two of the questions from the Slido just to clarify some of the overall settings. So the first one is and I think Javier, they are both addressed to you because you started one. The first one is about the step 5, and I think we mentioned that it is not included in the recommendation, but in the testing phase, but maybe, I don't know, Javier, if you want to elaborate on it. And the other question, which goes a little bit hand in hand, is also about, can we use the steps, are the steps sequential, or can they be used parallel?
On the first one, as you said, step 5 is not in the recommendation, although it is elaborated in the text that we will work during the testing period and think together with JRC and stakeholders how this could be integrated and if it is actually possible. And part of this work will be presented today already, so it is part of the testing phase. And then on the second, the way they are presented can be run in parallel. As data appears. I understand also from JRC that this is the way it has been done, but maybe Serenela, you can add on this aspect on the sequential or in parallel assessment.
Yeah. No, actually, again, the idea is you can run it in parallel depending on the scope. If the scope is to identify where a spot might arise, and because you want to, okay, say, for example, if you do it sequential to say I have 50 chemicals to select for delivering the same function, but I want to exclude those that are substance of concern or that are not passing the criteria 1, just to then zoom into my analysis of those that are, let's say, passing this step. You can do it sequentially, but if the idea is I have this chemical and on this chemical I'm concentrating, let's try to see in parallel in the different steps where I can act to improve that chemical. So it's really very much the logic of the application of the framework.
Okay, thank you very much. Any questions in the room? If not, I continue with another, maybe a little bit framing question, which says, did you only consider chemical by chemical substitution, or what about non-chemical solutions? I think it's good that we clarify that also.
Yes, this was actually a discussion we had also when we wrote the framework, because of course you might have non-chemical solution, and in many cases maybe you can even think about going from a product to a service. But besides jokes, we specified in the framework that this is just focusing on conditions where other possibilities are not at stake, but for chemical to chemical substitution. This doesn't mean that you have then tools for example, you can still say, I apply the life cycle assessment to the non-chemical option and see if it's bringing more benefits than burden. So this is, again, very much related to what is the aim of your application. But let's say the remit of the framework as it is today in our recommendation is for chemical to chemical substitution.
Thank you very much. I turn towards the group. Yes, please.
Thank you. Wiebke Lulsberg with BASF, but also co-chairing the network of experts as CEFIC. I would have a question now. I mean, you have taken a case that is quite mature. So you know the chemicals you tested are performing in the respective application you're looking into. Now, considering you were in an R&D situation, so you don't know yet the actual performance of your substance in the application you're innovating towards, I'm asking myself where and how is the actual additional performance criteria which I need, like the softening of the gas to get material, but also the tightness, for example, air tightness, where is that part of the assessment?
Let's say that this part of assessment is considering that what you are doing in your innovation in terms of functionality of what you want to deliver is anyway happening. I mean, this is the focus of the work you are doing internally in your company when you are innovating. So this is when you have a maturity in your innovation that is saying this function will be delivered. And then you are helped to say, in case you have alternatives, which alternatives perform better, or if you are constrained, so not so much alternatives, what you can do better to deliver that function. That could be, for example, in relation to the process, or for more health-related, for workers, for example, if you need specific DPI, or if you need so. But it's more in this phase. The issue will be, in my opinion, to have from your side a support to see how we can make the best out of the two processes in parallel. So how the innovation process for your chemicals and material is happening, and in which moment this kind of integration may help you the most. At the end, this is meant to help, not just to create an additional burden.
Okay, thank you. I turn towards the room again. Yes, we have 2 questions over here, and then we will take a few more from Slido. Please go ahead.
Hi, Michiel van Kuppenveld from the Dutch Association of the Chemical Industry. Thank you for the work. I was wondering, because now the scope is a cradle-to-grave scope, but as SSbD could be like needed for the circular economy. And there are quite specific scenarios for like one life cycle. Would the outcome be much different if you took a cradle-to-cradle approach for this case, you think?
Actually, we move a little bit out of the gate, sorry, because we included scenarios for the end of life. This, of course, it's part of what can be, because I mean, if we think about products that might have multiple uses, and this was a question in Slido, by the way, or that can have different end of life because it's produced in one country and then it's going sold in 10 countries with different scenarios for waste management. Of course, this is more a matter of understanding which is the variability, the potential variability of the results, or if there could be a specific recommendation, like saying this is better recycled than, I don't know, going to another end of life. But I think this is, again, something where it would be important to capitalize on the use of scenarios and understanding this variability rather than to say I have a number which is reflecting this case.
There was a second question there, and then afterwards, we will try to be a little bit more technical, more innovative, because then I will ask for somebody online to pose the question while putting on his camera.
sorry, the framework seems to be very well working, and we will see the challenges as well for existing materials. But as my colleague was voicing, for new chemicals, which is still in the innovation cycle, where there may be also data gaps, also considering SMEs in this context, how would these data gaps be addressed in such a framework when it's innovation cycle, there are many alternatives, but for example, SMEs may not have the right tools to address them. Thank you.
Yes, I think the question is anyway divided into, in the sense, the first part, which is related to new materials, it's also very much what will be needed in terms of further research and further methodological development, and this is also addressed by the different calls that RTD is launching. So which are methods that can be used at the screening level when you are in a TRL very, very low, to start saying, okay, maybe instead of taking the path A, I will take the path B, or how can I really automatize the assessment of how to move from one step to the other. And this is something very much where very much your input will be needed, but where also specific, let's say, investment are already in place to try to fill this gap. The issue of the SMEs, this I think it's a different issue, is an area where I see that probably we need to think about different actors helping. On one end could be that these SMEs could be supplier of bigger companies and maybe could be somehow mentored or helped, as it happened in other contexts where there was the need of producing data also to drive the innovation, or something where we have to see really the role of consultancy. Because in many cases, the consultant is also in other areas where those that were able to somehow multiply and magnify also for realities that are very small and might not have an expert in risk assessment, another in life cycle, and another maybe in social issues. So it's really something where we have to see the governance of this kind of application, how can work.
Can I complement? Yeah, I just want to say on what you once you said regarding we see these data gaps as a long-term perspective because we're not going to find a solution immediately. We are putting efforts and topics in the Horizon Europe Work Program to assist on this with the use of artificial intelligence and machine learning techniques to fill in these data gaps. And that we are also, in order to support SMEs, we have also a number of projects, and PAR will assist on this, on the develop toolbox and facilitate the assessment for everyone. And this will be fair and will be free, accessible for all stakeholders interested in applying it. So, but again, it's not a solution that is going to come in these 2 years of the testing period. We are research and innovation. We need to have this long-term perspective. And the focus here is also identify these hotspots and really put the efforts in order to solve them and facilitate.
Yeah, just maybe to add on it, the big partnership park is also looking into data gaps and how to address uncertainty and how to use artificial intelligence or other tools to try to overcome this. In their case, focused especially on the first step, on the risk assessment of safety. I would like to, so that we kind of try to make it a little bit dynamic also for the people online, I would like to ask the representative from L'Oréal to put on his camera and maybe ask his or her question, if that works. No, I don't seem to get a response, so then I will read out the questions. But for the people online, if you identify yourself, and I see that your question is coming up, you know, amongst those which are scored and interesting for people, I would very much welcome always that you then switch on the camera and ask your question. But the question here is about multiple users. What happened when there are multiple users? I think it's a good framing question also.
Okay, this I think it's another of the big challenge that we have ahead, in the sense that, of course, when we are embracing aspect of the evaluation of the specific use or the exposure of a user to the product or elements related to the end of life, this is very much application specific. So in principle, each application should have its own evaluation and its own study. Having said that, on the other side, there are already strategies to group chemicals by type of uses or by type of, let's say, hotspot that they might generate. But yes, in principle, the framework as it stands now, it's meant to cover a specific application. And this is also why we, at the end, selected a case study which is so specific, and you will probably read and comment also in the report, where even the type of food that is in contact with the material might generate a difference. So it's super case application specific.
Okay, thank you very much. I think, well, I think we can take one more short question and we move to the next session. If I see and we know this question, I think it is about SMEs, and can an SME handle all the steps? Javier, do you want to comment on it? The question is about SMEs. And can an SME handle all the steps, or how do we foresee? I think part of my reply is also that's why we are also very much incentivizing the development of toolbox, which are fair, which are accessible, where the information is there, where there are guidelines to help also smaller companies being able to then use the framework.
And I would also engage the SMEs to be part of this testing period and come to us and tell us which are the difficulties that they are encountering, if it is on any specific step or is the overall assessment, because then we can try to find the solution. But as Sophie said, our aim is to support the development of tools, make available the data, assist on the data gaps with R&I actions, to support SMEs, but also like other companies or academia that are interested in applying the method.
Sophie, Alexandra.
Very briefly to add, I just wanted to remind you about the very short time frame that is between publishing and adapting of the framework and now being with the first case study. So of course, we had to limit, because of time and human resources, the scope of the case studies to show really if the framework is implementable. But as mentioned before, and maybe something to worth also follow, a specific certain application and also perspective of different stakeholders will be addressed. And very soon there will be a circular economy stakeholder conference on the 27th of February, that we will listen the first perspective specifically on the small and medium enterprise that is, for example, involved in the projects that are being run and funded by Horizon Europe, also bigger companies and representative of a member state to show and to discuss their first impression and challenges they might encounter. And this kind of meetings will take place during the testing phase. So of course we are not able to address them all because we don't also know the specific challenges that specific stakeholders might be facing. That's why, you know, with the time foreseen for the testing phase, we really hope to have a clarity what specific challenges there, you know, specific users will encounter.
So I think I would just want again to try the technicalities, because we have another question, or we have a request for taking the floor where the person identified himself. So if I could ask the representative from the Austrian Ministry of Environment to maybe switch on the camera and take the floor. I think, is it possible? Yes, now, yes.
Yeah, great. Yeah, this is Martin Wimmer from the Austrian Competent Authority for REACH. I just would like to go a step back and come to the introductory part and have a few words on this. You said that this exercise not only addresses the specific sectors of industry, but also the member states who are now challenged to help in implementing the framework. And I would like to say we from the CA REACH Authority feel direct addressees of this challenge. And I would like to say first that we very much welcome the initiative because we think it is a significant step towards greening chemistry. And secondly, and therefore we want to support it. And I would like to reiterate an issue that I've already mentioned before in this context, and that is that we think that we should look at existing chemical legislation, especially REACH, to support that process. And when I heard that there are concerns of data gaps, very specifically, I think REACH registration would be a very, very efficient approach to fill data gaps, in fact. And for that reason, I would like to urge the Commission again, hearing that we have here not only RTD, but also Environment and GROW, who are responsible for the current REACH revision. I very much urge you to consider to make in this REACH revision this idea operational, because it will be very urgent, in fact, or it should be very urgent to help the process speeding up. Thank you very much.
Thank you very much. So it works. So the people online, if you identify yourself in the questions, you can actually, be seen from the room also. We have another question which has got quite a lot of scores, but I think we can take it when we move to I will keep it under my eyes, and we will take it when we move now to the next session, because it actually concerns a little bit step 1. So I would like to invite Iranfu to give the presentation of step 1, and then we continue with questions and answers afterwards.
Thank you very much, Sophie, and welcome everyone. Good afternoon. So yes, I'm going to talk now about step 1, how we implemented step 1 of the SSbD framework in the non-phthalate plasticizers in food contact material application case study. And for that, I will talk about first the goal and scope, as you see here in the slide. So here the goal of the first step is to identify in which hazard level the chemical material falls when applying the SSbD criteria. And we focus, as Serenella mentioned already, on the hazard intrinsic properties of the chemical, in this case, the plasticizers. So a short reminder, in this case, the SSbD criteria for step 1, it's based on the hazard classification under the CLP. And the criteria, depending on the hazard class and the category in which the chemical material, in this case the plasticizer, falls, will tell us whether the chemical passes certain criteria under the SSbD. And depending on this, we assign a level to the chemical material. Here, I would like to mention, and based on the experience, that the SSbD criteria goes beyond only assigning a hazard class under the CLP. In order to pass the different criteria under the SSbD for step 1, it requires as well to have available data in order to conclude whether the chemical is classified or not for certain hazard and category. Meaning that in this case, if there is no data, we consider the worst case scenario, that the chemical could be classified for this hazard class or category. Unless, of course, there is justification not to have this data because it is not required or it's not necessary. And in this sense, the SSbD framework promotes the use of NAMs in order to fill these data gaps in a tiered approach. This goes a little bit in line with the questions and answers in the previous session with regards to what happens when we are in the innovation phase and we don't have this data. The SSbD provides the opportunity to use these tools as screening tools to already identify where we could have a problem with regards to certain hazard category and class, and where we could have a problem, therefore, when classifying according to step 1 of the SSbD. And following, in this case study, we approach it in this sense. We followed a little bit this scheme, looking for all the available data, because in the case of the SSbD, we are allowed to that. We look in different data sources. We look for information with regards to phthalates, plasticizers, plasticized PVC, food contact materials, alternatives. We investigated existing methodologies, certification schemes, how to generate new data using NAMs, using in vitro approaches, QSARs, but also how to weight the value of this information, how to assess the quality of the different data sources and data information. And this that you see on the screen is an illustrative example of the exercise that we did. But as we have heard before, it's not a very simple exercise. It is very complex, so we acknowledge the difficulty, and we know that there are a lot of initiatives working on that. And in the case study that we are talking about today, we decided to take a most pragmatic approach, or a more pragmatic approach, sorry. And also linked to, I think, one of the last comments that we received, in this case, we took this pragmatic approach based on the nature of the case study. On one hand, the case study is based on existing chemicals in use and on the market, and therefore compliant with already existing EU legislation and requirements. And on the other hand, we needed transparent and comprehensive data source, because in this case we are not talking about only one chemical, but we are talking about six chemicals. So it happened that when looking, for instance, for information in databases and other kind of information, we could find information for one chemical but not for the other ones. So that's the reason why in the end we focus in the REACH, the ECA database. We focus on that because, as it's shown in the slide, first it has the information with regards to the hazard, harmonized official hazard classification under the annexes of the CLP. As you see here, for the DHP reprotox category 1B. If the ECA database also provides additional information with regards to non-harmonized classification for the chemicals in the REACH registration dossiers. In addition, in these registration dossiers, we can find the information supporting this classification for the physical hazards, the human health hazards, and the environmental hazards. And in addition to that, it also provides other information that will be necessary for the other steps, or at least for the safety steps. And it also provides information with regards to substances of very high concern. These are chemicals identified by the ECA Member State Committee as substances of very high concern that include, for instance, some hazard classes that today are not included in the CLP, like endocrine disruptors, therefore very useful information for the SSbD Step 1 criteria. And if we move to the next slide, this is what we found when we searched for this information, the first approach. We look for all the information that is needed for the SSbD criteria Step 1. And as you see there, we still saw that For DHP, of course, it is classified as reprotox 1B, an endocrine disruptor, but when you go to the other plasticizers, we could still find that there were some data missing. According to what I said before, the SSbD criteria for step 1 requires to have all this data in order to conclude and to pass to the different levels of the assessment. But as we mentioned as well, there is the possibility of assessing in a tiered approach. That doesn't mean that necessarily these chemicals don't pass the step. Is that further assessment, further investigation needs to be done. There is a need to justify the data gaps or generate new data using, for instance, as we have mentioned before, NAMs. And if you see in this slide, there are some justifications that can be used to understand why this data is missing. One of them could be that, of course, we focus on the REACH database, and we know that this REACH requires data linked to the tonnage band of the chemical that is placed on the market. In this case, this is not a justification because all the 6 plasticizers that we analyze are registered over 1,000 tons. Therefore, they should have all the entire registration dossier and requirements according to REACH. Data needed to conclude in some hazard classes are not required under REACH. And here, for instance, we can talk about the hazardous to the ozone layer or also the respiratory sensitization. Another justification could be that some of the hazard classes considered under the SSbD criteria are not hazard classes under the CLP. As we know, we are still in the discussion, or it needs to be the final decision on the endocrine disruptors classification under the CLP, and the same for the persistent, mobile, and toxic chemicals. Therefore, we could say that if these plasticizers are not listed in the SBHC list, that there is no existing concern with regards to these hazard classes, and therefore that they are considered as not classified. And last, it could happen that also data is missing because it can waive the data need. In this case, for instance, if we are talking about acute toxicity, we know that for chemicals with very low vapor pressure, this data is not required under REACH, and we could extend the same justification to the aspiration toxicity hazard, the sensitized explosives, or corrosivity to metals. And if we consider all these justifications, we already have the slide there. You can see that the picture is cleaner. And of course, we have identified that there are data gaps, as it has been mentioned, especially for the new hazard classes under the CLP. But we could conclude that all these data gaps have been justified, and therefore that the picture is clearer. And if we apply the criteria as proposed in the framework, in this case, we would say that all the plasticizers pass the hazard assessment step, DHP, that we know, as we know, it's reprotox category 1B and also endocrine disruptor for the human health and the environment. And if we move to the conclusions, I think that I don't need to say it, but step 1 is the most challenging step, because what we said, the data needs the complexity in generating the data, the expertise that is needed to assess the data. Tools needed to find this data. We discovered that there are not that many tools that can help searching for this data, the availability of data, because in most of the cases, this data belongs to industry, so it's not publicly available. And also a very important thing, and we are working on that, is how to assess the quality of this data, especially when we are talking about new alternative approaches. So said that, as it has been more than once mentioned, more cases are needed to test the framework and to learn from your experience.
Thank you very much. I think based on this slide with the conclusions, I will just take one of the top scoring questions which are here in the Slido, which says much of the case studies focuses on safety and harm, for which we already have chemical regulation. Should more focus be on sustainable by design? But I think you have already showed us that just the safety is also still a challenge to get it all done and right. Do you want to add anything on it?
No, I think that you mentioned very well. All the steps are challenging because there is still a lot of need of data and communication and passing the information through the supply chain.
Thank you. I'll look at the room. Any questions? Okay, we have, wow. Okay, we start with Eva. I will go down this way. I think there were 2 questions there, then 1 question here, then 1 question over there. You prefer them one by one? Or... Yeah,
okay. So Eva Schillinger on behalf of CEFIC. Thank you very much. I think you showed it also in the lessons learned. This is very impressive work that has been put together. Out of curiosity, could you share with us how big the team was and how much time actually went into this, just to give us a feeling for it?
You mean the team doing the step 1? Because in the end we work all together. I mean, all the team, SSbD team that work together. We are 2 units, F2 and 3, the 3, the ones that we work in this project. But we have a lot of experts helping us with the specificities of the different steps and the expertise needed for the different steps. I don't exactly know the number, but in the end, 2 units in the GRC working on that, plus our experts.
Yeah, Annika Bate from BSF as well, and also together with the IFRA Fragrance and Flavor Association. Thank you very much for that detailed analysis as well. And I've seen that you faced a lot of issues that we were already thinking about before, data gaps, and it's great that you accepted waivers, that you accepted also QSARs to say, okay, we have missing data, but nevertheless, it doesn't seem to be a problem. But as we've said already several times, you had a huge data set with that substances, yeah? So they had complete tox data, they had a lot of ecotox data, I've seen it. And yeah, and it's again a question, if you don't have the data, NAMs are great and we really support them. I mean, we are really active in developing NAMs, but there are, especially within the SVHCs, I mean, there are endpoints that are highly complex, adverse endpoints, cancerogenity, reprotoxicity, also endocrine disruption. It's not only modes of action, it's adverse endpoints. And then it's actually the next question, what would you think, how would you address those specific endpoints that are actually very adverse? I mean, you could do NAMs for certain modes of action that would cover some types of adverse endpoints, but never the whole picture. So in that case, you would actually either deviate from the CLP definition, or it would mean you have to generate with animal data. What would be your suggestion here?
I think that all depends in which stage of the assessment you are, because as we have mentioned, there is a tiered approach, and based on this and the expertise that is in-house of the expert judgment of the assessor, and this will guide you on the process, whether you need to continue scaling up in this tiered approach to the final stage where you need to comply with the existing regulations. Because in the end, what you are aiming at is placing this chemical on the market. But there is a tiered approach where it helps you to go using these tools that maybe they don't give you the exact information or the amount of information that you need to conclude in this hazard class, but it already gives you an indication, and you know whether you should continue this assessment or you should say, okay, here we have an indication that this is going to be an ED, therefore maybe I should stop investigating this chemical because I know that in the end I will have to do this test in order to place it on the market.
Can I add just on that, or or not? Yeah, but I completely agree. Of course, in the beginning, you would screen and get indications and then kind of sort out all the chemicals that would actually hint on that. But in the end, I mean, as we've heard, maybe REACH is going to get a bit more stricter on that, but not for all substances, depending on the application, depending on the manufacturer of how much you are actually, in which tonnage band you are, you would not do the big animal test that in the end would clearly identify an adverse endpoint. And then I just have the NAMs and just some sort of indication. But could I still do the SSbD assessment, although I don't have the final animal data?
Well, I think that this has already been mentioned. Of course, the SSbD assessment can be done, and the reason why step one is the first one, it's because it also influences in the other safety aspects. So you know that the hazard is this, it will influence in the risk assessment in step 2 and in step 3. That's the reason why it's a little bit this way, how it is structured. But that doesn't mean that if you don't have all the data, you cannot do the other assessments. That you have to consider that this data lack is still there. So in order to conclude on step 1, you still need to fill in this gap. But that doesn't mean, of course, that you cannot run the SSbD assessment. And of course, as we were saying, it's a tiered approach depending on the stage that you are of the innovation. The other steps as well will tell you whether it works to continue developing this chemical, because you have uncertainties with regards to step 1, but it can happen that you also have some problems running or assessing the other steps, or the other way around. It can tell you that it performs so well that you still will insist in step 1 and improving the information that you have in step 1.
Okay, I think we move to...
My name is Dominique de Becker from Solvay, and I'm... I should... Okay. So my name is Dominique de Becker from Solvay, and I'm running sustainability in business dimension. I'm not a toxicologist, no expertise in REACH process, etc., etc. And I see my role, and this is actually a mandate from the company, to kill as much innovation project because they are not good enough when it comes to sustainability, as an example. So the limitation I see, and I know it may bring additional complexity, the difficulty I see is that it refers to classification that are already recorded in databases. And from my perspective, I prefer, well, I will try to incorporate weak signals, even super weak signals on a specific product, even if it doesn't materialize in 5 years from now. But the money that will have been invested in the innovation project will bring me, at the end, a more robust business product, because it may last longer. Just looking at from an ESG risk perspective, or risk opportunity perspective, it's a better product, let's say, from an economic perspective, better investment for the company. So back now on what you have described, I cannot see in your approach elements that are not already registered in confirmed in database on hazard profile, etc., etc. But how could we then incorporate those elements so that ultimately we do have a more robust innovation, which is the aim at the end? I think we all share that common vision, and in the same time, having what you propose, I think makes sense and goes in the right direction. But I will see this at the, if not the last step, at the very end of the innovation project in order to verify that this we've not made mistake or make a wrong decision at earlier stage.
Okay, I'm looking at my colleagues. Iranzo, or should we hand it to Serenella?
Yeah, I will start because I only think I have a... so actually, this is the aim of the SSbD, not to wait until the last minute to verify this. It should go with the process. Sorry, that will be placed on the market, because until today that what has happened, and that's what we want to avoid, that we are learning about these effects of the chemicals once they are on the market. So that's what we would like to avoid.
So yeah, I'm completely with you on this, but I also need to think about the cost and the expertise that is involved in it. So we're running thousands of innovation projects in parallel. SMEs, it's a large company here, and having the resource available to use the full system at any stage will make it very difficult. So I'm thinking about PSA methodology of the BCSD as an example that probably is cutting corners to a certain extent, but using this as a, and we apply that methodology in my company for 15 years. So it's at the early stage when you need rough cut in the decision making, and then at the end of the process, then ensure that you are fully compliant with all this. And the other part that is missing is the rest. I mean, if we look at this from that narrow perspective, we may miss alternatives that are much better, but we do not take them into consideration, including other products that are contained in the same animal body object at the end of the day.
Yes, I think one other way, if I understood correctly, to formulate what you are saying is that we can think about a framework which has a sort of tier approach, because you have something which is a screening addressing this weak signal that is helping.
Yeah. Yeah, absolutely. It's innovation process. You start with 100, 200 IDs, then you end up with a limited number of IDs, and then you will start to fund them and start to make research literally. And I think we need systems such as that one that is applicable when I have to select among the 200 IDs the one that are likely to be at the end more safer and more sustainable. When I do have only 3 IDs, another system, maybe more sophisticated, more demanding, but that will confirm what has been said, and then progressively in this, which go alive with the, which go along with the innovation process as it is, so that you can take decision and kill them as soon, maybe ID level, you can kill them as soon as you may see that there is a better option to invest your money.
Maybe just a follow-up on this, because I think this is something that we also discussed, so it's a possibility. What I think will be quite important is that we move from, because you said, okay, simplified approach, but the simplify should not be a shortcut of certain concepts. Like, we on purpose put an example of a bio-based chemicals to say, okay, maybe one say, yes, my shortcut is that I go bio-based because I think that definitely it will be better, and actually it is not. So maybe, and this could be something, again, where the consultation might help a lot in understanding, I mean, in this screening level, what has to be captured, and also maybe already thinking about examples as the one that you made on the PSA, can couple with existing approach to do this screening, because this is anyway something you are doing with a different scope, but with this idea to have a funnel from many ideas to what actually you will invest onto.
For you, I'm fully with you, but I would prefer the two systems to be aligned. The PSA system and the SSbD framework to be aligned so that it's, if this is consistent, it's quite helpful to
Okay, as I think just for the sake of time, we take Henrik Edin had a question here also.
Thank you, Henrik Edin from ChemSec. And thank you so much for this presentation and for all the impressive work. I think 600 people listening to this is a testament to the importance of the safe and sustainable by design. My question is about the data. Of course, this is very interesting on this point. I think it cleared out, your presentation cleared out some parts of it. But of course, we think that more data can be used in this assessment. And my question is, do you plan on, or are you developing a model where all peer-reviewed scientific data can be used in this assessment? Because I think even though a lot of data is unavailable, there is data available, public data available. And now it's from the REACH HVAC list, the CLP, and from self-declarations that you have used. I am pleased to see that you have also considered a lot of other databases. But of course, I think it would be in the best interest of safe and sustainable by design, the framework, if we can include as much data as possible. After all, the framework is created to improve innovation, boost innovation, and to move beyond regulation. So that is my question. Do you have plans for developing a model where we can use all scientifically open, peer-reviewed data? Thank you.
Okay. I don't think that this is in the scope of the SSbD. Of course, we have considered, as I mentioned, there are a lot of difficulties in finding data, especially when you are looking for a specific data and when you are looking to be consistent in data. When, for instance, doing a comparative assessment, we did the exercise in this case. As it has been mentioned as well, when we started and we presented the case study, here was to test the applicability of the SSbD framework as suggested by the GRC, and not that much to assess the chemicals and to score there. So the assessment is not complete because what I mentioned before, the complexity, the huge work that it still needs to be done, and we already heard about different initiatives in this sense. So yes, we hope in the future that will be develop some kind of tool that where we can find all this information without going crazy as we did.
Okay, I think we will try to take a few questions from online, and I know there seems to be a problem that we also need to unmute microphones at the same time when I ask you to speak. So we're trying to speed up the coordination between me mentioning somebody and the colleagues unmuting microphones. I have a question from Jan from Unilever. If you would like to put your camera and micro on and ask your question.
Hi, can you hear me?
Yes.
Great.
Excellent.
Okay. Hi, everyone. Yeah, thanks very much for the presentation. I mean, it's going to be a great couple of days this, so I'm really looking forward to it. I think my question's probably been addressed actually with the previous questions, because it's really around data availability and particularly early in innovation. So I guess picking up from my colleague from Solvay and actually probably the ChemSec question as well, which is really how do we collect data or use data that is available, which may be quite non-standard data from other sources of data, referencing the ChemSec question or from new approaches, etc. I guess it's about how do we use that effectively for chemicals that are early in the innovation phase in order to do that assessment against this step. So I think that's probably the question. I think it's already been discussed. I like the idea of a tiered approach, perhaps. So when you're early in innovation, you can do certain, I don't know, predictions or other types of methods which can give you information as to whether each of the endpoints are relevant for that particular chemical that you're developing. I think the problem is maybe linking it so strictly to the CLP criteria. You're not always going to have that level of information that will enable you to do that assessment at particularly early in innovation. So I think the question's been answered, but I mean, if anyone wants to talk a little more on it.
Yeah, me too. I think that it has been answered, but okay, it's important to insist on this. I think that, as I mentioned, this, although it looks straightforward, especially because it's based on already existing criteria to classify the chemicals, we acknowledge the difficulty of gathering the data and the complexity as well of assessing this data and be able to conclude in the different hazard categories and classes. But we have also mentioned all the possibilities that the SSbD brings, like the possibility of assessing in a tiered approach, the possibility of using alternative methods, and also, of course, we know that these are available depending on the step or the TRL that you are when you are innovating and developing new chemicals. So all these things, together with the quality, of course, of the data, something that I have already mentioned, that it will be as well need to develop something that reflects depending on the TRL that you are, what is the data that you have available, and what is the quality scoring that it can be given to this, no? Considering, for instance, the timelessness or the availability, because it's not the same if you are talking about having a QSAR when you have a lot of testing data available, or having a QSAR when you don't have any additional information available. How we weight this, so all these things are being considered, and as well as all the initiatives that are taking place in other projects. So we hope that in the future this will be able to be integrated in the SSbD framework as well.
Okay, great. Thank you.
Okay. Thank you. I'm looking at the room again, and yes, we have a question here again.
Hi, thank you. I would just like to add on that question, because it was very interesting, very good question. Actually, to rather, because I have the research in mind, to probably better focus on hazard classes that are really important in your application. Because if you think about, for example, plant protection products against some cosmetic products, yeah, plant protection products, I would really focus rather on environmental endpoints, because I really apply them in the environment, while for cosmetic products, I would rather focus on human health issues, skin sensitization, etc. And maybe also, I don't know if you would consider this, maybe also rank, I don't want to say rank, but it is probably better to focus early on those important hazard classes, and also consider later on sustainability advantages together with those hazard classes, instead of directly focusing also on all other hazard classes, to pick out the best substance that has, for that application, the best hazard profile. Maybe it has additionally a skin sensitization, which can be really easily addressed when the worker exposure is reduced or something like this, but has a much better sustainability profile, instead of in the first just, searching for all hazard classes and then going on in the sustainability. Some sort of, I think I've said it before, sector-specific search Like in which application do I go? Which are the most important hazard classes that I need to cover? And then go into sustainability aspects that are maybe more important, and maybe in the end, but really focus on the important ones, both in the hazard classes and also in the sustainability assessments.
No, I think in general what we have said already is that you can play with the different steps. You know, you can do them in parallel, and you can look at the sustainability while you're looking also at your safety or hazard issues. So I would say this is also what we need to learn now with testing the framework, and how do we approach it, and what is the best. Ideally, of course, you should do everything all the time. That would be the nice. But now, if you say I want to focus first on those hazard classes which are the most important for me to see if I succeed there, I then do my sustainability assessment to make sure that I'm on the right track. Then you can go back afterwards and also say, and I now look at the other hazard classes also, because I know that my big line is right. I haven't got any bigger mistakes, to avoid doing assessments on your way which might not be needed because you fail in other parts. So I think as long as what we would like in this testing phase is that you also document your thinking, you know, how have you done it? Why have you done it that way? What is behind it? So that we learn about the different approaches taken. I don't know if my colleagues want to add anything.
I just wanted to add, I mean, it's a little bit complement what you said, but because in the end, what we want is to assess according to the criteria, or that could be improved in the future, but according to the SSbD criteria as it is presented in the framework, how you do this, because of course it's an iterative process as you are developing your chemicals for the specific sectors. How you decide what is important for each of the steps depending on the stage of the innovation that you are, it's part of the innovation. This helps you to complete the data set that you will need in the end in order to certify or to assess according to the SSbD framework your chemical.
Okay, I think we will take one last question here from the Slido, and then we will have coffee break. So then you are welcome to also continue the discussions in the coffee break. There is a question, and it's unfortunately anonymous, so I cannot have the pleasure of calling somebody on the screen. The question is, I think, look at my left side and my right side. Will there potentially be guidelines, tools for multi-criteria decision analysis and more complex decision-making in innovation? So the question is about guidelines.
Yes, I think that part of this work that we are expected to do in the next years will be to help applying certain part of the framework, but also somehow detecting those that are developing tools or approaches in order to capitalize this knowledge. I see very much the development of this framework in terms of being more implementable as a collective exercise. So really a collective intelligence in saying we might have different tools, different approaches and different methods towards this goal.
Okay, thank you. I suggest we break for coffee now, and we have half an hour coffee break. So also for the people attending online, please be back at 4:15 again. We will start sharp so that we can also end sharp. And there is coffee for those present here. There is coffee outside, and there is also fruit so that you have good energy for the next session. Thank you. Okay, so we will be starting again. I was just asked, and I will do it now before I forget it at the end, to remind you all that tomorrow there is also council meeting. So slightly more difficult ways to access will continue tomorrow also. So please take that into account when you come for the session tomorrow morning. And then also you saw there were some queue after lunchtime when you entered. Tomorrow morning it will be the same, so please be early so that we can start on time, because we have a long morning tomorrow morning. Thank you. Then, so we will now move to step 3, and in the...
Step 2.
Oh, yes, sorry, too fast. Step 2, and afterwards in the Q&A session, we will start then with the Slido questions, and then we will take questions from the room afterwards. So it's my pleasure to hand over to Iranzo again to present step 2.
Thank you, Sophie. So I think that we can skip the first slide. You know already more or less what I am going to cover. Here to mention as the goal of step 2, that in this case is to identify if during the production and processing of the chemical material, in this case the plasticizers, pose any risk at the workplace. And here, as a reminder of you, although you very well know, the risk and how we assess the risk is based on the hazard of the chemical material and its intrinsic properties. That's the reason why, as a first step, we do the hazard assessment of the chemical, but also we assess as a component of the risk how the worker is in contact with this chemical, how much, what are the exposure routes, what is the time, the duration, the frequency of the exposure. And in this stage, on this step, we have to cover the different activities that take place in the different processing and production stages. In the specific case study, we cover the manufacturing of the plasticizer, the formulation of the plastisol, as well as the plastic lid/gasket production. In this case, the end of life have not been covered because we have considered that is the same as the metal closures, and that basically goes to the municipal waste flow, but it should be considered in other case studies. So if we go to the next slide, here as well, and I will insist, because I think it's very important, as in step 1, that what it is proposed in the framework is a tiered approach as the information becomes available with regards to the hazard properties of the chemical, but also the information that we have with regards to the exposure, the different uses, and the contribution activities during this production or processing of the chemicals, in this case, the plasticizers. And here, as an illustrative example, you have some of the tools that are already in use, especially under REACH, and that have been mentioned in the framework. But of course, we know as well that a lot of different tools exist and that are used depending on the needs of the case and the expertise of the ones that are applying, and the applicability of the tools that not always are applicable for all kind of chemicals. So in this case, we also took a kind of pragmatic approach when choosing the tool that we were going to use. We chose KESAR, the tool developed by ECA, for several reasons. One is because, at least in my opinion, has a very user-friendly interface. So that already helps when there is no expertise. We were discussing about who is going to apply the framework, SMEs. So I think that this tool is very user-friendly. But we chose it as well because it provides the possibility of importing information that it's already in the Euclid format in the registration dossiers. In this case, we did not have this opportunity, but as I mentioned before, we extracted all this information from the ECA database, and it also provides the possibility of inserting this data manually. It also contains the built-in exposure tool that we identified as one of the most appropriate ones for this specific case study, that it's the SETOC TRA, because it has been developed under the context of the REITs, and as we said, we retrieve a lot of information from this data, the ECA database. But it also provides the possibility of importing data from other external exposures tools, as well as experimental measured data. And in addition to that, it also provides the possibility of importing use maps developed by sectors organizations. These use maps were developed under REITs with the intention of defining the use and the use conditions under the different sectors organizations for the particular products in an harmonized and structured way. And why I say that, it's because actually when discussing with the different sectors of organizations while building the case study, defining the case study, we identified as the European Plastic Converters as a key organization in this value chain. And we also identified that they develop use maps to define the uses and the contributing scenarios that we were looking at, namely the plastisol formulation and also the articles manufacturing that you can see in the left-hand side of the screen. In addition, we add, of course, the use scenario of the manufacturing of the plasticizer, and for this we focus in one extended safety data set that we found for DHP with a lot of information, and we decided to use this information as the basis of our assessment. I have to mention that for the use maps developed by UPC, they didn't provide information with regards to the operational conditions, but some guidance with regards to that. So as a first approach, a little bit as we did for the step one, a tiered approach according to the information that was available. As a first approach, we consider a not very realistic and not very good scenario that you can see in the left-hand side of the slide, the information that we included as the operational conditions. For instance, for all the scenarios, we consider that the concentration of the plasticizer is 100, what is not the case. It is in the manufacturing process, but not in the formulation of the plastisol or the gasket. We also consider that there was no local exhaust ventilation, that the working hours were 8 hours per day, and we consider some high temperatures in the processing. And there in the right-hand side of the slide, you can see the risk characterization ratios that were estimated by the KESAR tool. However, we tried and we received information from some companies working on the sector to refine these operational conditions, and we did a second iteration of the process with this additional information that we received from them. And you can see in the next slides, this one for the formulation of the plasticizer, for the gasket production, and for the manufacturing. I will go a little bit fast through these ones because otherwise I won't have time to finish my presentation, but it's just an illustrative example to see how, as data becomes available, the refinement of the exposures can be made, and then the results are more realistic, and they can demonstrate in most of the cases that the use is safe. We still have to analyze what is the information behind that in some cases derives that some of the plasticizers are less safer than others in some activities. Like for example, we have identified that ATVC has the highest vapor pressure, and that's the reason why in some of the scenarios the risk associated is higher than for the rest of the plasticizers. And I don't know, yeah. And in this step, we also consider to cover the environmental aspects as part of the contribution scenarios provided by EUPC. And we did approach it in a similar way as we did for the human health. In this case, we did several iterations providing different input data to the tool in order to estimate as well the risk characterization ratios. The first approach was to use the information that we retrieved from the ECA database. This information was not complete, so we used some QSARs in order to estimate these data gaps. As a second exercise, we use QSARs to estimate all the different PINEX. And that was all for the PINEX. Now we move to the PECs, and we did a similar exercise. So in this case, we have 3 different scenarios. We use as well the experimental data extracted from the ECA database for the derivation of PECs in the first case. For the derivation of or estimation of PECs in the second case, we use QSAR data. And the third sample or the third table illustrates the PECs that were estimated by QSAR using more realistic data retrieved or extracted from this ESDS that I mentioned before. And if you see in the next slide, what we identified as a good point is that, for instance, if we are doing a comparative assessment, the tool, it's very useful because depending on the chemical properties, it gives you a good example on how different are the risk characterization ratios that the QSAR tool can provide and how to differentiate the chemicals, the plasticizers in this case, that perform better and that don't perform that well. But still, as you can see in the first table, because we use very conservative release factors that by default uses and QSAR provide, that all the risk characterization ratios are above 1. Of course, as we said, and we will insist on that, the better data and the more refined data, the better. And in the second table, you can see that using all this data that we retrieve from this publicly available ESDS, we have different results. And in this case, we can say that in most of the cases, also the risk to the environment is prevented. And if we move to the next slide, here we propose system of scoring based already on the proposal in the framework, but developing a little bit further, where we deciding for the complexity, because of the complexity of the process, a kind of a scoring based on the different procs that we have for the different steps and based as well in the different ERCs that we can have for the environmental assessment as well in the different stages. So here, first, we look at the procs and we propose to have the 4 levels depending on the RCR's results for the procs. If the RCR, the combined RCR is below 1, and all the individual RCRs are as well below 1, we propose a level 3. If the RCR is above 1, but all the individual RCRs are below 1, we propose a level 2. If the total or the combined RCRs are 1 and at least one of the individuals ones are as well above 1, the level is 1. And the last one, if all the combined RCR is 1 and more than one individual RCR is above 1 as well, we propose a level 0. This, of course, for each of the stages have to be aggregated because, as you know, we have different procs for the same scenario. And the average gives us the result for the different stages. For the plasticizers manufacturing, for the plastisol formulation, and for the gasket production. And the same for the environmental assessment as well. In this case, we only have one ERC, and for this example, we took the worst case scenario, and that's the reason why all of them have level 0 based on the first iteration that we did for the assessment. And in the next slide, you can see the same exercise for the formulation of the plastisol and the production of the gasket. And then if we move to the next one, here we have as well the results for the overall assessment in step 2, therefore considering the manufacturing of the plasticizer, the formulation of the plastisol and the plastic article, and combining the human health and environmental aspects. And as a result, in the first table, you have the SSbD level for step 1, considering this worst case scenario when all the environmental aspects or the different plasticizers don't ensure the risk. And in the second one, the same example, but in this case, consider the last scenario where we demonstrated that in most of the cases the environmental aspects were considered safe as well. And conclusions. So in this case, the overall conclusion would be that this step is very challenging because of its specificity. Of course, we can do the assessment considering the worst case, as has been demonstrating, generalizing and taking the most conservative approach, and we see that the results are very concerning, let's say. But we could also go to the specificity of the company, the knowledge and the data information, and more realistic risk assessment, and this improves the results of the assessment as well. Here, important to mention for the case study and for other cases that for the comparative assessment, the consistency of data is very important. We know and we have learned that in some cases we can have experimental data for some chemicals, but QSAR data for others. So consistency should be ensured in order to also ensure a good comparative assessment in that sense. And I think that a little bit in line with what we have already said for step 1, expertise is needed to build the scenarios, to use the tools, to also know what information with regards to the intrinsic properties of the chemical are relevant for the exposure assessment and the risk associated to this exposure, but also to assess the results. That as in step 1, a tiered approach is possible, and that this demonstrates that as data becomes available, the assessment performs better and the chemicals perform better with this additional information. And then as my last step, and this is more an open question with regards to the environmental assessment, that of course demonstrates to be more difficult than the human health one, where there is more knowledge, that in this case not in this case, that the environmental performance and assessment will vary depending on the case study. Here, I mentioned that we added in the step 2 because the use maps covered the environmental release category, but also because, as we will see tomorrow, we identified as not that relevant for step 3. So here it's, we also receive some comments in this context of why it is not covered in step 2, the environmental assessment. So this is something to consider, that we are considering, and whether it should be in step 2, in step 3, or in both. And it's as well an open question to be discussed, and that we hope that we will receive feedback from you in the testing of the framework. Again, don't know whether it's there, but more experience needs to be gathered, and for that we invite you to participate in the testing phase.
Okay, thank you very much. So I think we will start this time with the Slido questions, and I would like to ask Gita Egberts to eventually turn on her screen and ask her question.
Thank you. So I have some experiences with REACH registrations. And when I look at what is presented here, it's a complete REACH assessment for each of the substances. And I know it's so I have two different questions. So the one is what I wrote down is that CISA and isotopTRA are not do not give reliable results in case you rely on measured values. So it is a real worst case approach, and I'm not sure how you would like to address those substances that are where you have measured values instead of using those theoretical values for the risk assessment. And the other question I have, how should a small company, so an SME, carry out such a huge amount of work of assessing, so more or less carrying out complete REACH registration during an R&D project?
So I hope that I understood correctly the two questions. The one was referring to how to do this assessment if there is measured data, correct? Yeah, so this is, I mean, in this case, we didn't have this measured data, so that's the reason why we decided to approach using these tools, and specifically KESAR and SSbD, but it's part of the iterative process tiered approach that has been mentioned. It is not that these tools have to be used. These tools are available if this data doesn't exist. Of course, they don't substitute if there is existing measured data.
Mm-hmm.
And the second one?
The second one was, it is more or less a complete REACH assessment for all users of all the substances within an R&D project. And so for me, it is overwhelming, to be honest. So I have difficulties to understand how an SME could manage with that.
Yeah, well, I think that this question has been also addressed in step 1. Is something that we are considering as well, how to improve or how to facilitate the possibility of SMEs running these assessments, but and tools will be developed in this sense, or at least there is a call to develop tools in this sense. And I don't know, I will hand over to...
Maybe I can add on this. I think the more we all start getting practice with applying this framework, and the more we start sharing our experience, the easier it also will be to know, as information becomes available, as things become findable, as we know which methods and which tools are out there, it will be easier then for everybody also to assess their substances. And I got lost myself what I was trying to say. I was trying to say that it is experience we need. At the moment, we are at the very fresh start. We are confronted with something we need to learn about, and this is why we are entering a testing phase so that we can really make it more accessible to everybody. You know, when the first smartphones were on the market, we were also looking at them like something very bizarre to use, and now it's kind of you do it, you know, without even thinking about it. So I think it is a learning process, and this is really why we also think this testing phase now is so important, that we really work together and share the knowledge which we acquire while using it. I keep my,
I would like to add something because here actually I think that more challenging that as for step one, more challenging than actually assessing the performance of the chemicals, materials, is accessing the information. There is a lack of information communication in the supply chain in order to build, in this case, the scenarios. We have found, I mean, we have this challenge when discussing with the different companies or the different sector associations, that even for them was difficult to understand what upstream or downstream was happening. So here the challenge is also to communicate and to communicate in an harmonized and structured way in order for us to facilitate, for all to facilitate the assessment.
For me, it is really difficult to understand how this could not hinder but improve innovation.
Thank you very much. I think is there any questions in the room? Yes, please, down here.
You can hear me? Thank you very much. Dratna Priska from Zero Waste Europe. I must say I not entirely understand why you exclude this end of life of these gaskets, because, well, apart from the sustainability issue that is single use, it's not recovered and recycled. When it's ending in the municipal waste, the only thing then it would happen is landfilling and incineration, which per se actually has clearly some chemical safety issue. Especially if this is PVC, the incineration actually also is related to creating dioxins, etc. So I just wonder why you have actually skipped this part. Thank you.
So maybe before the skipping, because you mentioned that there is a concern with regards to the PVC, but here a reminder, it's not the PVC. What is being assessed is the plasticizer in the PVC. So, and then I hope that I can hand over to Davide for this one, because I don't remember exactly.
But for the occupational safety.
Yeah. No, the decision of that it goes to the waste stream.
Okay. No, I mean, we considered for tomorrow, we will see briefly for the environmental sustainability, also the end of life of the gasket. In that case, for the environmental performances of the product. But here we were talking about the occupational hazard, which is different. So, I mean, we consider it like the end of life scenario, but for the environmental part, not for the hazard, the occupational hazard, because I think this was part of the framework to stop at the before the application.
Yeah, maybe I can add on that. So there were some discrepancies when how to consider the end of life of the plasticizer in this case. But as you said, in any of the cases we consider incineration and as the end of life of the plasticizer. And for this reason, with regards to the occupational safetiness, we consider that everything goes to the environment in this case.
So do I understand well? So if that would be recycled, then you would include the occupational exposure from the recyclers. Okay, thank you.
Okay, thank you. I think I will just take one of the questions from the Slido, and I would really encourage it. it works very nicely to make you speak, but so I would really encourage people to identify themselves when they ask questions, because it makes it more interesting than me reading them out. I think I will address this one to Serenella. The question is, the risk assessment does not differentiate between DHP and the alternatives. How useful is that assessment if it does not differentiate?
This is something we were discussing this morning on the discriminating power of the current framing of the different, let's say, classes for the SSbD. So this is something we have for sure to take into consideration in the further refinement, so to improve the discriminating power of each step. Because as those of you that seen already the report, there are steps that using certain classes and classification schemes results in basically similar results.
And I think then I will do something a little bit challenging, because we see a lot of votes going on here for a question about the mixture assessment factor. And I would like the person who posed this question to explain to us how we have to understand it in this context, because it's not clear for me, I must admit. So if the person who posed the question about the math could please turn on their camera, introduce themselves. No, you can, we can. The problem is that we don't know who you are. Can you please then ask the question again by introducing yourself, so that we can turn your micro on, and then we can maybe tackle it later on. But for the moment, we cannot give you the floor because you're anonymous. Sorry. We move on to another, if the question's in the room. Can you?
So it's
Can you hear me now?
Yes.
Yes?
Yes, we can hear you.
So hello, Josephine Renaud from the Association France Chimie. I've been very, very heavily involved in this possible introduction of a mixture assessment factor. So for the moment, they're thinking of putting a uniform value, not only for environment, but also for human health. And we've done a lot of studies, and if you introduce a very large or even a small value of 2, you will see that the RCRs go through the roof. And so that's going to be a big problem in the environmental part that you showed. I don't know if that is clear, if it's understandable.
Thank you. I'm looking at my colleagues.
No, I mean, it's understandable, but this is something that it's been discussed in parallel. I think that's one of the actions of the CSS, and it will come the future where we have to consider it, but it's not at the moment something that we are considering or discussing.
Yeah, I can understand that, but it could come even before the REACH review, because it could be introduced in an annex. It could come sooner than later. So it's just a point to keep in mind.
I think note taken, and thank you for clarifying what was behind the question.
Thank you.
I'm just, can I have Bart Walhoed from RIBM? RIBM, Bart?
Yes, okay, sorry, I couldn't unmute my microphone. Thank you very much for the opportunity to raise my question. A couple of minutes ago, there was the assertion that we are at a fresh start with the framework, which is correct. But the steps taken, as has been pointed out also by BASF, are sort of equal to what has been obligated for REACH registrations. So perhaps there can also be lessons learned from these REACH procedures when it comes to obtaining data. You don't have to find out yourself, perhaps. So has there been a broader consideration of what are the lessons learned in REACH, for example, about obtaining data that can be applied also in using this framework?
Yes, of course, and I think that, I mean, we will receive, I hope that more feedback in this sense in the testing phase, but as far as I know, one actually of the challenges in order to complete the assessment is as I mentioned before, the information flow. Knowing upstream and downstream how the chemical is used and applied, that's one of the main challenges, I would say.
Yeah, okay.
Okay, I look at the room again. Any questions in the room? No, if not, I will take the question from Trevor Fielding. So Trevor from yes. Good.
Can you hear me? Thank you very much. Thank you very much for accepting my question. My question is that many of our members' raw materials are sourced from outside of the EU. How can they ensure that their products are not penalized under SSbD due to lack of especially step 2 data? Thank you.
Can you please repeat? Basically, if I summarize the question, the question is about yes, raw materials which are sourced from outside of the EU. How does this impact the assessment in step 2?
I think that I don't know the answer to that one. Yeah, I think that it's actually one of the problems that are already existing within REACH, for example, what happens with imports and how we can ensure that they comply with the legislation and that we have all the data needed available. So,
yeah, yes, I think my comment is really that step 2 is the challenging one in terms of actually assessing the procedural side, the actual processes, and our members don't have access, of course, to how their suppliers are manufacturing their materials. That was my point. Thank you.
But I think the point is taken and acknowledged. Okay, I look again at my room. It's been an intensive afternoon, I think. I can see people, no questions here in the room. I will take one more from Slido, and then I maybe also have a little bit of concluding question afterwards. So I have Anna Morao.
Hello, I'm here in the room actually. So I can phrase my question. We had now the question about the suppliers not being included or when they are coming outside of Europe. But if I see your assessment that you just showed, they are not included at all for the impacts of the exposure of the workers, correct? The production of the precursors for the pacifiers. Why are they excluded? That's my first question.
Well, actually, we discuss a lot about this because they are considered for the LCA aspects. But here, and this is the approach that we took, and it's open for discussion, but as we are considering the risk associated to the chemical, we consider that in this case the precursors are not part of the chemical, and then therefore they are considered in the manufacturing process, of course, as the precursors of the manufacturing of the plasticizers, but what we are following really is the risk associated to the plasticizer.
think I would just, to come slowly to an end, like to pick up of one of the questions which was there this morning also, and which I actually was thinking about keeping to the end of the presentations of the 4 steps, but maybe we can take it now just to close the day. And the question, I need to see if I can find the, yeah, okay. So if John Eastwood would like to ask.
Yeah, I was hoping you were going to save that question until tomorrow as well. Maybe that's a good discussion point to finish off the session tomorrow as well. But my name is John Eastwood. I represent Additive Technical Committee, so representing fuels and lubricant additives in Europe. And my question was, do you have any advice on how to choose case studies? We've only gone through 2 steps, so I guess that's why I was hoping you'd take it tomorrow when we've done all 4 or 5 steps, and then you can kind of highlight which you think are the most important steps for consideration, or is it just step 1, the hazards that we should take as our starting point?
I don't know whether it's for me, because I think that this can be open for anyone. I think that the first one is the most concerning one for everyone, because it has this cut-off criteria, but it's also because, as I mentioned before, it has something to do, at least for the safety aspects, step 2 and 3. And also because we know that actually the aim is to replace the concerning chemicals from the market. No, this is the starting point. That's the reason why we have the CLP criteria, and that's the one that actually it's going to tell us whether we can place a chemical on the market or not. But said that, I think that it depends on the approach that you want to take. It depends a little bit on the strategy of the innovation. I would say that it is easier to start from this aspect, from the safety aspect, maybe the hazard aspect as well, because as far as I understand from my colleagues, the LCA assessment is even more complicated and there is less data there. But I would recommend the opposite. Now let's generate this data in order to make it in the future more available and more easy to also perform the LCA assessment.
In terms of, if I can add a bit, in terms of prioritization, I would say one of the objectives when we started working on the SSbD and why is it included in the chemical strategy for sustainability is to develop alternatives to substances of concern. So if you are aware in your sector that there are certain substances that are problematic either for the health, human health or the environment, I will prioritize the application of SSbD there and find alternatives that are safe and sustainable, right? But as we always say, SSbD is open for all chemicals and materials, so that doesn't need to be focused on the hazard profile. Also looking at sustainability part, if you have aspects, you can improve the processing of this chemical or material to make it more sustainable or more circular. This is also an aspect to prioritize the application of SSbD.
Okay, thank you. I think I would like to come with this discussion and we can continue it tomorrow also after the next 2 steps. If there is no more urgent questions at the moment, then I think we can close the meeting for today. I would thank you all for coming. I would thank you all the people connected online to have been there. As we said before, please remember that it might still take a little bit more time to reach the venue tomorrow morning. There will still be security checks all over. We start at 9 o'clock. So also, again, please be on time so that we don't get too delayed because you're all stuck in the security queue. And I would thank you very much for the meeting today. And we look forward to continuing tomorrow.